Welcome everyone to my channel.
Question number 101. The depth of footing for an isolated column is governed by maximum bending moment, shear force, punching shear. Option D is the right answer. All three. Suppose this is the isolated footing subjected to the loading. So the depth of this footing is calculated by three criteria. And these three criteria are one-way shear, two-way or punching shear, and bending moment criteria. So by one-way shear, the critical section will be at a distance D from the face of the column. This is the column of dimension A and B, and this is the footing dimension X and Y. Okay, so this is the critical section for one-way shear. Will be at a distance small d from the face of the column. Small d is the effective depth of the footing. So by two-way shear or punching shear criteria, the critical section will be at a distance small d by 2 from the face of the column. Next, bending moment criteria. By bending moment criteria, the critical section will be at the face of the column. So depth of isolated footing is calculated by this following three criteria, and highest value so calculated is adopted in the design for the calculation of overall depth of the footing. Question number 102. If the foundation of all the columns of a structure are designed on the total live load and dead load basis, then the settlement of the exterior columns will be more than the interior columns. Option C is right answer. We all know exterior columns will be at the periphery of the structures, and exterior columns are subjected to more weight and pressure and live load as compared to interior column of the structure. So the settlement for the exterior column will be always more than interior columns. The extra weight and pressure will cause the exterior columns to settle or sink more. Question number 103. To minimize the effect of differential settlement, the area of a footing should be designed for dead load and fraction of live load. Option C is right answer. Question number 104. The critical section for finding maximum bending moment for footing under masonry wall is located halfway between the middle and edge of the wall. Option C is right answer. Question number 105. In a file of length L, points of suspension from ends for lifting it are located at 0.207 L. Option A is right answer. Suppose this is the pile of subjected to the loading W per length. Okay, and suppose this pile is lifted by this 2 point. Okay, here and here. So this is the length of suspension at left side, and this is the length of suspension at right side. Okay, so we know total length of the pile is L. So this length is to be, so this length is to be determined. This length, suppose this length is A and this length is A. Okay, so if we consider it as a beam simply supported but two-way overhang beam, so we can calculate the distance A, and this distance will be 0.207 L from this point. So the point of suspension will be at a distance 0.207 L from the end of lifting. Question number 106. During erection, the pile of length L is supported by a crane at a distance of 0.707 L. Option C is right answer. From the driving end of the pile which rests on the ground. Question number 107. While designing the piles as a column, the end conditions are nearly one end fixed and other end hinged. Option C is right answer. Suppose this is the pile driven into the ground. So the pile is always designed as one end fixed and other end is hinged. This is the one end and this is the other end. Okay, so this end is driven into the ground and this end is designed as hinge end and this end is designed as fixed end, because this end hinged because this end can rotate, not restant against rotation, but this end is fixed, this end cannot rotate. So pile designed as one end hinged and one end fixed. Question number 108. The recommended value of modular ratio for the reinforced brickwork is 40. Option C is right answer. Question number 109. According to ISI recommendations, the maximum depth of stress block for balance section of a beam of effective depth D is. Suppose this is the RCC rectangular section of dimension with B and effective depth D, and this is E is the effective cover. This is the strain diagram. The strain at the top is 0.0035 and at here strain for steel is 0.87 Fy divided by ES plus 0.002. ES is the yoke modulus of the steel, and this is the stress diagram for this section, rectangular at the top and then parabolic. So the compression force will be from this section 0.36 FCK
B into XU, where FCK is the characteristic compressive strength of concrete.
and tension force will be at this level 0.87 Fy AST. Fy is the yield stress of steel and AST is the area of the steel.
So, by the properties of similar triangle from strain diagram, we can write
The maximum compressive strain at here 0.0035 divided by this distance xu, which is equal to the strain at here 0.87 Fy divided by Es plus 0.002, and this distance d minus xu. And suppose this is the balanced rectangular RCC section, so xu will be equal to xu max, so we can write xu equal to xu max. So after calculation we will get xu max divided by small d equal to 0.53 for Fe 250 grade of steel and
0.48 for Fe 415 grade of steel and 0.46 for Fe 500 grade of steel. So, option B is the near option.
Question number 110. Assertion A. The load factor for live load is greater than that for dead load. Reason R. The live loads are more uncertain than the dead loads. So select your answer based on the condition coding system given below. Both A and R true, and R is the correct explanation of A. Option A is right answer. Question number 111. The centroid of the compressive force from the extreme compression fiber in limit state design lies at a distance of. Suppose this is the RCC rectangular section of dimension with B and effective depth D, and this is E is the effective cover. This is the stress diagram for this section, rectangular at the top and then parabolic. So the compression force will be 0.36 FCK
BXU, and FCK is the characteristic compressive strength of concrete.
Suppose this is centroid of this compressive force acts at here. So distance of this compressive force from top extreme fiber will be 0.42 XU. Near option is 0.416 XU. Option B is right answer, where XU is the depth of neutral axis at the limit state of collapse. Question number 112. The design of yield stress of the steel according to IS 456/1978 is 0.87 into Fy. Option D is right answer, where Fy is the characteristic yield strength of the steel. Question number 113. According to Whitney's theory, ultimate strength of concrete is assumed to be 0.3%. Option C is right answer. Question number 114. According to Whitney's theory, the depth of stress block for a balanced section of a concrete beam is limited to 0.537 D. Option B is right answer, where D is the effective depth of the beam. Question number 115. The load factor for live load and dead load are taken respectively as.
2.2 and 1.5. Option B is right answer.
Question number 116. As per Whitney's theory, the maximum moment of resistance of the balance section of a beam of width B and effective depth D is given by. Suppose this is the rectangular section of dimension. Suppose this is the rectangular RCC rectangular section of dimension with B and effective depth D. This is the strain diagram, and this is the actual stress diagram by Whitney's theory, parabolic stress diagram. Okay, but Whitney considered the stress diagram as the rectangular section. Whitney replaces this diagram as rectangular stress diagram. Okay, so the this is the average compressive stress at the top, and this is the depth of stress block of distance a, and we all know the depth of stress block by Whitney's theory is 0.53 d. So we know the compressive force will be C equal to 0.85 into FC dash into area of the stress block A into B. Okay, and if we want to calculate the moment of resistance by the compressive force, we have to multiply the compressive force with the lever arm, and the distance of lever arm will be d minus effective depth minus a by 2, because this is rectangular section, this distance is a by 2. So moment of resistance will be equal to c into within bracket d minus a by 2, and a is the depth of stress block 0.53 d. So by the calculation we will get moment of resistance equal to 1/3 fc dash b d square, 1/3 sigma cy into b d square. Option B is right answer, where sigma cy is the cylinder compressive strength of the concrete. Question number 117. The maximum shear stress for M15 concrete as per IS 456 1978 in limit state design is 2.5 Newton per millimeter square. Option A is right answer. Question number 118. According to IS 456 1978, maximum compressive stress in concrete for design purpose is taken as 0.446 FCK. Option C is right answer, where FCK is the characteristic compressive strength of concrete. Question number 119. The maximum compressive stress in a concrete for design purpose is based on a partial factor of safety is equal to 1.5. Option B is right answer. Question number 120. The partial factor of safety for steel as per IS 456 1978 is taken as 1.15. Option A is right answer. Question number 121. According to IS 456 1978, the maximum strain in the concrete at the outermost compressive fiber in the limit state design of flexural member is 0.0035. Option B is right answer. Question number 122. Minimum eccentricity for design of column as per IS 456 1978 is L by 500 plus T by 30. Option B is right answer, where subjected to a maximum of 20 mm, where L is the unsupported length of the column and D is the lateral dimension of the column in the direction under consideration. Question number 123. For the deflection of the simply supported beam to be within permissible limits, the ratio of its span to effective depth as per IS 456 1978 should not exceed 20. Option B is right answer. Question number 124. The development length of bars of diameter phi as per IS 456 1978 is given by. Option B is right answer, phi sigma s divided by 4 into tau Vd, where tau Vd is the design bond stress and sigma s is the stress in the bar. Question number 125. For bars in tension, a standard hook has an anchorage value equivalent to a straight length of 16 phi. Option C is right answer, where phi is the diameter of the hook. Question number 126. The creep strains are caused due to dead loads only. Option A is right answer, because creep strains are the long-term deformation under sustained loading. Question number 127. The effect of creep on modular ratio is to increase it. Option B is right answer. Humidity of atmosphere and passage of time. Option A is right answer, 1 and 2. Question number 129. Due to shrinkage stress, a simply supported beam having reinforced only at the bottom tends to deflect downward. Option A is right answer. Question number 130. In symmetrically reinforced sections, shrinkage stress in concrete and steel are respectively tensile and compressive. Option B is right answer. Question number 131. A beam curved in plan is designed for bending moment, shear and torsion. Option D is right answer. Question number 132. In a spherical dome subjected to concentrated load at the crown or uniformly distributed load, the meridional force is always compressive. Option C is right answer. A dome structure is rounded roof or ceiling like structure that resembles a half sphere. Domes are self-supporting structures that do not require any column and supported by the force of gravity, compression, tension and thrust. They can be made from variety of materials such as stone, glass or metal, and can be also from RCC. They are often used in the sports arenas and government buildings. Question number 133. Sinking of an intermediate support of a continuous beam reduces the negative moment at the support and increases the positive moment at the center of the span. So correct answer is option B. Question number 134. The maximum value of hoop compression in a dome is given by WR divided by 2D, where W is the load per unit area of the surface of dome and R is the radius of the curvature and D is the thickness of the dome. Question number 135. In a spherical dome, the hoop stress due to a concentrated load at the crown is tensile everywhere. Option B is right answer. Question number 136. In a ring beam subjected to uniformly distributed load, shear force at the mid span is 0 and torsion at the mid span is 0. So option A is right answer. Question number 137. In a pre-stressed concrete, force of tension and compression remain unchanged but lever arm changes with the moment. Option B is right answer. Question number 138. The purpose of reinforcement in pre-stressed concrete is to impart initial compressive stress in the concrete. Option C is right answer. Question number 139. Normally, pre-stressing wires are arranged in the lower part of the beam. Option B is right answer. Question number 140. Most common method of pre-stressing used for factory production is long line method. Option A is right answer. Question number 141. Select the incorrect statement. Statement A. The loss of pre-stress is more in pre-tensioning system than in post-tensioning system. Right. Statement B. Pre-tensioning system has a greater certainty about its durability. Right. Or statement C. For heavy loads and large spans in building or bridges, post-tensioning system is cheaper than pre-tensioning system. Right. So option D is right answer, none of the above. Question number 142. Which of the following losses of pre-stress occurs only in pre-tensioning and not in post-tensioning? Elastic shortening of concrete. Option A is right answer. Question number 143. Pre-stress loss due to friction occurs only in post-tension beams. Option A is right answer. Question number 144. The coefficient of shrinkage for high grade of concrete for pre-tension work is 3 into 10 to the power minus 4. Option A is right answer, where T is the age of concrete in days at pre-stressing. Question number 145. Which of the following has high tensile strength? Cold drawn wires. Option B is right answer. Question number 146. High carbon content in the steel causes increases in tensile strength but decreases in ductility. Option B is right answer. Question number 147. Stress strain curve of high tensile steel does not show definite yield point but yield point is defined by 0.2% foot stress. Option C is right answer. Question number 148. Select the correct statement. Statement: elastic modulus of high tensile steel is nearly the same as that of mild steel. Option A is right answer. Question number 149. Cube strength of control concrete to be used for the pre-tension and post-tension work respectively should not be less than 32 MPa and 35 MPa. Option B is right answer. Question number 150. Ultimate strength of cold drawn high steel wires decreases with increase in diameter of the bar. Option B is right answer.